Hey guys, we're going to work on the surface area and volume of cones in this video. A cone consists of a circular base and a lateral area which comes to an apex at the top. A right cone will have its height run perpendicular to the radius such that the height connects the apex and the center of the base. To get this started, we're first going to redraw a picture of a cone on our own. I'll give you a couple pointers on how to draw a cone, and then we will just rewrite the volume and surface area equations and try this cone example. So let's get started. The first thing I like to do, especially when drawing cones and pyramids, is I like to draw a circle the way you would draw the circular base of a cone. Even though it's a perfect circle, from a certain angle, it does give this more of an elliptical shape. Now, this shape is going to help us when we draw pyramids in the pyramid video. And as long as the base of your pyramid is a regular polygon, or really any polygon, you can use this oval to help you out. But in this case, the oval really does represent the circle base, and it will remain the entire base. Like, we're not going to have to modify it. Then I like to put a point at the center of your oval here. If you're not sure where the center is, you could kind of draw a few lines, diameters through this center area and see where they cross to kind of figure that out. Then I'm going to go like this and determine how tall I want my cone to be. This point right there will be my apex. Then I draw straight line. It looks a lot better when you use a ruler, even though, we try to be straight. We draw straight lines here. And this is the radius. Sometimes I like to switch up and draw one line more dotted and one line more dashed to really highlight the differences. And here, that's the back. And this is the front. And there's the right angle. The H stands for height, and like I said, the height connects the apex to the center of the base. R stands for radius, which is the fixed distance between the center of the base and its circumference. And S actually stands for slant, height. So if you were to figure out the height of this cone slanted, so from right here to here, what would it measure? Keep in mind that the Pythagorean theorem is definitely going to come in handy, because sometimes you'll be given the slant height and radius and have to figure out the height or some other combination. You may even get an angle measure, perhaps this angle over here, maybe the whole entire top angle, and you'll have to cut that in half. And then you can use some right triangle trigonometry to figure out the missing components. Now let's rewrite the equation for our surface area. The surface area formula is a little bit harder to really understand where it all comes from, because it's not as classic in these shapes that we see when we unassemble something like this. So the area, or surface area, like to use SA, is the area of the base, but that part's pretty easy, pi r squared. We should be experts at that by now. Plus, here we have our surface area, the lateral one. That means basically everything else on this cone, going all the way up to that apex right there. And the equation for that is pi r s. So radius times slant height times pi. The volume equation is pretty interesting. All of these solids that come to a point at the top, an apex, if you were to pull a cylinder to a point that had the same height, same radius, it would make some sort of a cone, right? Well, one of these cones, fun fact, a cone that would fit inside of a cylinder such that they have the same radius and same height would actually have 1/3 of the volume. So if you were to fill this cone cup with water and then pour it into a cylinder, with the same radius and the same height, you would actually find that it would take 3 fills, 1, 2, 3, to fill this to the brim. So our volume equation really shows us how this is true. Volume equals 1/3 of, and of means multiply, 1/3 of the volume of a cylinder, which is pi r squared, the area of the base, times the height. So the volume of this pointed cylinder is 1/3 the volume of the cylinder. Now let's try this cone example. So in this cone example, we are given the diameter. So we need to pay attention to the fact that the radius is actually going to equal 7 feet and the height is equal to 18. That's all fine. But what is the slant? Since we aren't given the slant height, we're going to need to use the Pythagorean theorem like I mentioned before. In the event that the directions ask you for an exact answer and you end up with a radical, just leave the radical in the answer because leaving things with a radical is the more precise way to do things. 7 squared plus 18 squared equals s squared. 49 plus 324 is equal to s squared. So s squared equals 373, which actually doesn't even simplify. So s is equal to the square root of 373. It is what it is. We're just going to leave it like that. Now, let's go ahead and do the surface area and volume with this information. Surface area will equal pi times 7 squared plus pi times 7 times the square root of 373. Clean that up. Pi times, now remember, it's 7 feet. 7 feet times 7 feet. Not only does the 7 square, but feet squares as well. So you end up with 49 pi feet squared plus, and I'm just going to rewrite this as 7 pi square root of 373. You could leave the answer like this, or, oh, and then this was feet and feet, so it still gives you feet squared. You could leave the answer like this, or if it were multiple choice, you might see someone factor out the 7 pi because it's the greatest, the biggest possible common factor, the biggest possible common thing that you can factor out or undistribute from each of the terms. And then that would leave a 7 plus radical 373 inside those parentheses and feet squared at the end. Either way, all good. Next up, we're going to do the volume for the same example again. Volume is 1/3 the volume of the same cylinder, so pi r squared, 7 squared, h, which is 18. I would take this 1/3 and apply it to the 18. 1/3 of 18 is 6. Now all you need to worry about is 49 times 6, and we're going to leave pi in the answer. 49 times 6 equals 294. 294 pi feet cubed, and that's because we had feet, so it's cubic feet. Areas, surface areas, areas of a polygon, area of a circle will have squared units, and volumes will have cubed units. So I hope you like this little mini lesson on the surface area and volume of cones, and I hope it helps you figure out the surface area and volume of cones on your own.